Well, hello, students, chemistry students. I miss you guys. So it's Wednesday at about 2:30. So this may be the last of the notes I give you, because at this point it's going to be just a whole series of connecting different conversions together. So, you should have just seen the previous video, which was set up for this Monday. We just got the MVP triangle. So we know that we can convert grams into moles if we know the molar mass. Okay, and that was the page you worked on where you had all of the atomic weights filled out. So molar mass, don't let that throw you. That page right there, we figured out all those molar masses. If you want to figure out how many atoms or molecules you have, we can use Avogadro's number to convert between the number of moles and the number of atoms or particles, and we already know how to convert moles into mass and grams. Later on, we'll be giving you X amount of grams. In fact, that's going to be the mixed mole ones coming up. In fact, you probably already had that already. So now what we're going to do is, down below I asked you to have this attached in there. This is the double MVP triangle. And this is what we use when we are trying to figure out how many, let's say we give you how many grams of a reactant, and we want you to figure out how many liters of gas will be formed, or how many grams of a chemical will be formed from there, something that dropped out of solution maybe, or even how many molecules. So what links one chemical here, now on this page here, I've got that label down there as chemical A. Let me make that just a little bigger. And then chemical B. Chemical A, chemical B. So when we're working these problems, whatever the and I'm going to say this will be the given side. So we may say you are given 12 grams of zinc. Okay, this is the given side. And if we want to end up over here on the find side, so chemical B is our find, maybe we want you to find how many molecules there are of a chemical that's formed. So maybe we started over here with grams of zinc. You would have to follow this. You'd have to divide by the molar mass of zinc to get moles. Then what we're going to do is we're going to use what we call the mole to mole ratio to connect this MVP triangle to this one. And with the mole to mole ratio, look at right here. We're using a balanced chemical equation, and we're using the coefficients. Oh, coefficient. I think I put too many T's in there. Coefficient. Sorry about that. Too many F's in there. So when we have a balanced chemical equation, the coefficients on that balanced equation are going to be the moles of the chemical we're trying to find, and we'll divide it by the moles of the chemical we started with, that we were given. All right, so let me go to another page. Oh, good. I got this on the cover. Excellent. This is on the cover of your packet. You might want to grab that, and then you got that to look at as well, okay? So let me give you a fairly well-known, okay, so we're going to go to page 17, mole to mole ratio. Okay, let me write down, first off, when we do these problems, we need to have a balanced chemical equation. So I'm going to put this one right here. If you have nitrogen gas, like you might have from the atmosphere, and if you react it with hydrogen gas, I believe this is called the Faber process, where how they make ammonia, or for industrial uses, it'll form NH3 ammonia. Now we got to get the coefficients here. We've got to have 3 hydrogens and 2 of the NH3s over here. So 2 ammonias, and I'm going to go ahead and just put the coefficient 1 there. We don't need to. So here's a balanced chemical equation. So let's say in this one, for the mole to mole ratio, this is going to be, let's say our given is, the question is, let's see, given, let's say we have 70 grams of nitrogen gas, N2. Let me back that up. No, let's say given 1 mole of N2. Now, when we look at these balanced chemical equations, we're no longer going to say 1 molecule of nitrogen reacts with 3 molecules of hydrogen to form 2 molecules of NH3. We're now going to say 1 mole of N2 will react with 3 moles of hydrogen gas to make 2 moles of NH3. So from now on, when you see the equations, we're done balancing them. We're not going to make you balance them anymore. We'll give them to you already balanced. You've got to know we've got a ratio of, for every 1 nitrogen, there's, well, let's do the ratios here. Yeah, let me skip here. Let's do ratios here. The ratios of nitrogen to hydrogen. Okay, now when we say nitrogen in these problems, nitrogen is in the form of N2 and hydrogen is in the form of H2. So what's the ratios? For every 1 nitrogen, we've got how many hydrogens? You got it, 3. So if we were given this and we were trying to find how many moles of hydrogen gas we'd need, our ratio would be what we're trying to find. 3 moles of hydrogen would be on the top of our equation, divided by 1 mole of nitrogen. Because remember, when we're going from the given, I'm going to label this on the front. This is the given side. We're giving you a chemical. The moles of what we're trying to find, this is the find side. Let me make sure I've got that zoomed in up there. Over there. Okay, there we go. So whenever we set up this mole to mole ratio, the moles of what we're trying to find goes on the top. In fact, I'm even going to label this. Moles of the chemicals to find divided by the moles of the chemical we were given. Now, this is always from the balanced equation. Don't go get mixed up and say, oh, the problem said I had 2.5 moles and I'm going to write that in. No, no, no. When you do the mole to mole ratio, it is from a balanced chemical equation. Let's see. What's the mole ratio for nitrogen to ammonia? NH3. Make sure we're zoomed on there for you. Well, let's see. We've got, for every 1 mole of nitrogen, we've got 2 moles of NH3. So we have a 1:2 ratio there. And let's try this now. Let's say, what's our ratios of hydrogen gas to N2? Well, let's see. We've got, for every 3 moles of hydrogen gas, now these numbers here are all moles, okay, but we're turning them into ratios. And those ratios, we're going to end up turning into those conversion factor fractions. For every 3 moles of hydrogen, we have, well, look at there, 1 mole of N2. Or you can say, for every 3 moles of hydrogen, we're going to have NH3 there. We're going to have 2 moles of them. So we're just setting up a ratio. This is key because once we've converted these chemicals to moles, the balanced equation here, these number of moles in the balanced equation, we set them up, we find the ratios, turn them into a conversion factor, and it allows us to leave what we were given and jump to the chemical MVP triangle for the chemical we're trying to find. So these ratios are going to be important to what we're doing. So with that, mole to mole here, let's write mole given over here, and we're just going to make MVP. We're just going to make a simple MVP triangle there. Oh, sorry, I'm in your way. Sorry, let me back up there. Okay, so we have all of our ratios there. Just making a simple MVP triangle. This is moles of the given here. And we're going to now, when we jump from the given chemical to the one we're trying to find, we're going to jump now to moles of what we're trying to find. And I'm going to put the MVP. At this point, we don't really care. We're not worried about the molar masses or the volumes or the number of atoms. All we care about is this ratio. And as always, when we were working with the MVP triangle, whatever we're going to goes on the top of our conversion factor. So if we're going to moles, I'm going to call this compound B, compound A. We're going to the moles of the chemical we're trying to find. So from the balanced equation, how many moles of compound B are there? Moles of B, compared to how many moles did we have of the chemical we were given? Moles of given compound A over here. Okay, this is the given, this was the find. So now let's go back to that problem I was starting to make earlier. Let me zoom out here a little bit. All right, so let's say we are given, let me strike that one. If we are given 3.5 moles of nitrogen, which in this equation nitrogen exists only as N2, how much hydrogen, H2, will we need? How much moles? We'll just say moles because we're just doing moles to mole. Oh, that is terrible. Let me zoom in there. Hopefully you can read that. Given 3.5 moles of N2, how many moles of H2 will we need? Okay. So, well, don't freak out. Always just start the given over 1. Here's our given. 3.5 moles of N2. Now, a little trick I recommend is that with an MVP triangle, the double MVP triangle, with a pencil, very so you can see the thing. Okay, I'm just going to label this. Our given was N2. I'm just going to lightly put N2. And we're trying to find in this problem, we're trying to find out how much hydrogen. So the find, I'm just going to label this H2. So we're jumping from moles of the given. So the given is 3.5 moles of N2. Now, that's how we start every stoichiometric mole conversion problem. The given over 1, include the unit and the chemical. Zoom in. Okay, now we're going to connect, jump from here to there, we just need to do our mole ratio. So we're going to multiply it by, we're already in moles, you don't have to worry about anything else, we've given that to you. And so now we need to put the moles of the chemical we're trying to find. We are trying to find H2. And in our balanced equation, we have 3 moles of hydrogen. So we're going to say for every 3 moles of hydrogen, H2, then we got to divide it by the moles of the chemical A, or the chemical we were given, from the balanced equation. In the balanced equation, there's 1 mole of N2 for every 3 moles of hydrogen. If I can diagonally cancel, if you can diagonally cancel those out, you've set it up right. Now, let's do 3.5 times 3. Oh yeah, that should be 9, 10. Is that 10.5? I'm just doing that in my head, but I want to make sure. Let's see. 3.5 times 3 equals, okay, 10.5. Equals 10.5 moles of hydrogen would be needed. So, we got our answer here. Looking back at the big picture, since there is a 1-to-3 ratio, however much nitrogen we have, we're going to need 3 times as much. And that's what this equation did for us. We started with 3.5 moles of nitrogen. So we're going to need 3 times that 3.5 to start with. So these ratios will help you get through this. I've got a getting started video for the homework that will follow on this one, which is in your packet. It will be, let's see here, the mole to mole. Okay, in here. That's mixed mole, mole to mole, there we go. So we got problems over here. You're just going to set them up the same way. You can go to my getting started video to help you with those. All right, take care of yourselves. Follow those rules. I know being teenagers, you want to break from your parents, but right now you've got to follow their rules because they're trying to keep you, well, you alive, but primarily they're trying to keep other people around you alive. It's really important to self-isolate. I miss you guys. I love you guys. I sure wish you were here, and I sure hope I get to see you in my classroom again.